So number 15, it involves the equation of a circle, which we have not gone over yet in this class in the year 2020, depending on when you're watching it. I skipped over it, and we'll come back to it later. I skipped over it because I didn't know if we'd be able to get everything in time, and this is something that you do again in pre-calc or math analysis, so I felt like this was one of the things that was safe to cut out. So that's the equation we're dealing with. All circle equations are in this form, or that are in this form, allow you to identify the center and the radius. And later on when we formally learn it, I'll get into why. But just how in this equation, y equals mx plus b, right? That's the equation of a line. You know that m, the number in front of x, b multiplied by x is the slope, and b, the number being added to the slope times x alone, is the y-intercept. With the equation of a circle, just like you can look at this and find the slope and the y-intercept and thus graph the line, you can look at this purple equation, and this h and k tells you the center of the circle, and r is the radius. So it's x minus the x coordinate of the center squared, and then y minus the y coordinate of the center squared, and then equals the radius squared. So this circle is going to be centered at 4, -2, and have a radius of 5. Alright, so once you know that, this question's a little easier. So now I'm going to sketch that, and I'm going to put this point at 4, -2. So I should make those different. Okay, so 4, go 4 to the right, 1, 2, 3, 4, down 2. So that's my center. And then the radius is 5, because this is always equal to the radius squared. And it has to do with the distance formula, if you want to look into it, but I promise we'll go over it eventually. Alright, so that's another point on our circle. That's going to be 5 units away. This will be 5 units away, and that'll be 5 units away. So that's what our circle looks like. And the pentagon, and again, this distance right here is 5. And then the pentagon is inscribed in the circle. So it would look something like this. Okay, not perfect. And then the pentagon, you could break it up into triangles. And then now we know that this distance here is equal to 5. And that's 5 as well. And since there's 360 degrees in this full rotation here, 1, 2, 3, 4, 5, all 5 of those angles add up to 360. Alright, each of those angles is going to be 108 degrees. So when you go to split it, because this is an isosceles triangle here, it creates 2 angles that would be 54 degrees. Alright, so now we need to use that 5 and that 54 degree angle to figure out, we'll call this x. This is also equal to x, which should be the base of our triangle, and then this part here, y, is going to be the height of our triangle. So to find x, since x is the opposite leg to 54 degrees, and we know the hypotenuse, we're going to use sine. So the sine of 54 equals x over 5. When you cross multiply, you get x is equal to 404, which means that this entire base here, this entire side, is going to be double that. It's going to be 8.08. So that's going to be the side, one of the sides of the pentagon, and then, or the base of that triangle. And then to find the height, you could do cosine, because y, the height of that triangle, is adjacent to 54 degrees, and then we know the hypotenuse. When we cross multiply, then we get that the height is 2.938, so 2.94. So it's base times height of each triangle divided by 2. So base times height divided by 2 gives us that area. Then we multiply it by 5. So now type that all in our calculator. So I do 2.94 times 8.08 divided by 2 times 5, and we get that the area of that entire pentagon is about 59.4 square units.